make sure you're on code.org. Wherever you are on code.org, go to your name, Hi, and Code Studio. This time you really need to follow along, okay? Code Studio, and then scroll to where it says 20-hour courses for computer science, and click Course 1. We're going to do Course 1 first. This is where all of it begins, and now you see the progression later on. Ready? Okay, now you have all the puzzles, right? Let's put our cursors, don't play yet, cursors on the first circle next to stage 1. When I say go, that's when you click that, okay? And there is another unplugged activity in the next line, right? Do not watch those anymore. Just skip them. I am trying to see if you can figure all of these out on your own. Remember, these are pre-reader puzzles. So no need to watch the next 2 videos also, okay? But if you ever need help, give me a thumbs down, thumbs to the side, or flag, post it, and I'll come and help you. Other than that, it's an independent work time right now. Ready? 3, 2, 1, go.
I'm on course 1. Being nosy.
Okay, so we're going to continue with what we call an unplugged activity. Before we get started, we continue with that, I would like to invite you with our call and response, because basically unplugged means we're not using the computer at this time. So in this case, I would like to actually request that you put your laptops on clamshell mode, which is 45 degrees. You're not turning it all the way down, but just 45 degrees, so you're not typing and you're not looking at the screen, but you're still ready to just turn it back up when we're ready to pick it up online, okay? So thank you. At this point, we are going to do, that's my timer. We're going to do what we call a Teaching Learner Observer Activity, or TLO. And what I'm about to do will be to model one of the lessons that is called Unplugged or Offline from the book or from the curriculum guide. For the next 30 minutes or 20 minutes, doesn't have to be that long, I am going to be the teacher. And I'm going to pick a lesson from the book and teach that to you at your level. You will all be first grade students, the best first grade students I've ever had. And you're going to try to pretend that you're just at that level for this simulation. If you have any questions as an adult or as a teacher, don't interfere. Stay in character and just pretend you're in first grade. Our observer will be Renee, and what her role is just basically to engage us in a collaborative conversation at the end, when we take off our hats and come back to reality as adults. And she will lead us in discussion, just looking at the idea of how does this look like in terms of instruction. We're focusing on pedagogy, on teaching and learning, not necessarily, oh my God, this is computer science and I don't know what I'm teaching, but what I want you to be engaged in is to see how it looks like in the classroom and how whatever strategies, resources, or materials, or things that you're already doing, how do you just integrate all of those into the lessons, or vice versa, okay? So at this point, I would like to invite you to put all your hats on, whatever role you have, and stay in that character, because we are just getting started, okay? So we are supposed to be offline, so I'm just gonna leave it there. Thank you, boys and girls, for having your laptops on clamshell mode. And also thank you for coming back from your very short recess of 10 minutes It's a summer school class, so that's why we have a modified schedule. And also, normally I don't let you eat in my classroom, but today is a special day. So it's okay if you eat and at the same time learn from what we're about to do, because guess what? We are going to learn about what we call Unplugged Lesson. I went to this workshop last week, and it is one of the best workshops I've attended. The facilitator was the best, so I'm going to come back, and I'm so inspired to teach you the lesson. We're learning about what we call getting loopy. That's the name of the lesson we're about to get into. And as students, you will be able to repeat actions that either myself or a volunteer is going to do. And then let's have a volunteer table to read the second objective. The front, middle front. What's the second objective? To translate. Picture program into a live action dance. What that means basically is we're going to have a dance party. So make sure when we get to that point, you're all ready to get up and dance, okay? And the last one is the back table. If you can see it, sorry. Or everyone who can see it. Convert a series of multiple actions into a single loop. And there's the magic word for our lesson today, is the word loop. Okay? In computer science, and you probably saw this in the computer lab. Remember, I took you to the computer lab this morning. You were doing coding for 30 minutes. So now we're doing kind of like an extension of that, but face-to-face. And you probably saw the word loop. I'm not sure where you are in terms of the puzzles, but that's what we're learning today. So I'm going to invite you to kind of give us an idea, what do you already know about that word loop? It can be an example, a word that means the same or synonym. I know I haven't taught you that, but what are some of the other words that come to your mind when you see this word loop, okay? So instead of you just yelling it out loud, I actually want you to talk to your elbow partner and think and then pair, and we'll share out loud. So the next 2 minutes, we're going to be talking amongst each other. Okay, I hear some great conversations, some movement, and words that mean the same. Okay, let's pretend 2 minutes is over. So I haven't really engaged this back table. Any word that comes to mind when you see that word loop? A circle, okay. And you see what kind of graphic organizer or thinking map are we using right now in our first task? It's a circle map, okay? So circle map is to basically just define something in context or to brainstorm. So right now we're crowdsourcing, we're brainstorming what do we know, prior knowledge about the word loop. And that table says it's circle, okay? Starts from one point and goes back up to that point, and again and again. Any other examples? It can be an object, something you see.
Reminds me of the Earth.
The Earth. Why is that?
Because it's round.
It's round. So I'll put those two. When something is round, what happens?
No beginning, no ending.
Beginning, no ending. It's a sphere. So because this is a positive classroom, I'm going to write everything that you say because there's no wrong answer, okay? So it begins, no ending. What's another word for no ending? Infinity. Wow, first graders. Now, let's bring it back down to first grade level. Did you have an answer? Spin, okay? In what way can you relate the word spin? Hula hoop, okay? So those are some of the activities that you do on the playground, on the yard, that you are actually making some loop. There's another word. Remember when we started talking about how the water starts from the ground, goes back up, blah, blah, blah. What do we call that? A cycle, okay? Or a spin cycle for a washing machine or something like that. Now, remember when you were in kinder last year? Right? Remember that? How fun that was?
There now.
And I was your teacher, right? Now, it's not that you repeated kinder, because right now you're in first grade, but in teacher language, I chose to loop with the best students I have. So now I am still your teacher, okay? So that in our understanding is what we mean by loop. But in computer science, just like what you've seen when you were playing the puzzles this morning, in computer science, we are going to just define the word loop as the action of doing something over and over again. Great job. We have an advanced student here in the front. Over and over again. Why don't you actually demonstrate how that looks like for us? Let's see. You want to get up and show how that looks like in reality? Yeah. What's your name?
Mercy.
Mercy. Mercy is going to perform some actions. just like when you were, let's give her a big round of applause. Just like when you were playing the puzzles. No, you're not done yet. Just like when you were playing the puzzles, you have to read the instruction first, right? What is it asking you to do? And then click run. I'm going to kind of do the same thing for her, except she is just going to receive the instruction from me, and we'll see how she's going to run the program.
I have to go to the bathroom, teacher.
Too late. You've been so advanced, and now you're backing up.
I really gotta go.
Is this your adult self or what?
That's what first graders would say.
Okay. Now, Mercy. Walk around the chair.
I don't have to wait for my mother made out of it.
Walk around the chair. Don't pass out.
Don't pass out.
Walk around the chair. And walk around the chair.
Eventually you don't have to go to the bathroom anymore.
And stop. Okay. What did I ask boys and girls, your classmate, to do? To walk around the chair. Could I have given her the instruction in a simpler, more efficient way?
Yes.
What did you notice when I gave her the instruction many different times? What was she doing? Yes.
Oh, I noticed that you kind of said walk around the chair every time she hit the same space.
Absolutely.
Same clip.
And what could have I done or said?
Repeat it. Walk
How would that sound like?
Sounds exactly the same.
Walk around the chair until I tell you to stop.
You can do that. How can I be more explicit and specific? Walk around the chair 4 times, okay? I could have just said it once, and then she should have just gone through it. But I was asking you what was she doing? She was waiting for me, right? What's the
Waiting for
next instruction? So she was looking at me like, is this over or what? I just need to go to the bathroom. Or I could have just said, hey, Mercy, walk around the chair 1,000 times. I'm the one who needs to go take the bath. Use the bathroom. And she could have just kept going, and I come back, she might still be walking around the chair, okay? Now, before we give you a big round of applause, I want to ask you a question. Do you have some moves? You know how to dance? Sober? Okay, she does. So, can we keep you? You're good, right?
Do I have some moves? I don't know. I have to dance.
Yeah, you do. So stay there. So let's hold on to that applause because she still has something to do, okay? We did one instruction. They're all the same. Just walk around the chair, but just 4 times. Now let's see if Mercy here can actually perform multiple instructions. Let's see how. Okay, right here, we'll give her some time. I also place copies of this in the middle of your table, so you want to take a look at it. But right now, Mercy will lead us through acting these out, okay? You can call out the actions as you perform them,
Oh, okay.
okay? So watch first, and then we will all do it together. Mercy, I also have a copy, yeah. In the front,
Oh, I can
okay. But they want to see your face as you perform
Oh.
it.
Well, now I need my glasses.
Sorry. Your first grade.
First graders, yeah.
Yeah, but first graders don't have.
Can you see it? I mean, it's okay if you turn around.
Right.
Okay. Let's look at the first line. What does Mercy need to do? Can you do that, Mercy?
Okay, ready? Clap.
1,
2, 3.
great job. Next.
Okay, now behind your head. Put your
Waist.
hand behind your head. Like this. And now put your arms on your waist. Put your arms behind your head again. And put your arms on your waist again.
Okay, that's the second line. Third line.
Okay, we go back to clapping 3 times. Ready? 1, 2, 3. Now, head.
Left up.
Is it left up?
Yeah. But we're gonna raise our right because they see the first graders, they get disoriented. So left up, right up, left up, right up. Next. And then clap, clap, clap. What's next? Yes, what did you say? Absolutely, because you're forgetting that outside of the bracket is you have to repeat this inside 3 times. So let's do all those inside again in a more efficient way. Okay? Faster if we can. 1, 2, 3. Clap, clap, clap. Head, waist, head, waist. Clap, clap, clap. Left up, right up, left up, right up. Clap, clap, clap. Back to the top. Clap, clap, clap. Head, waist, head, waist. Clap, clap, clap. Left, right, left, right. Clap, clap, clap. And now you can laugh. Ha, ha, ha. Well, we added you the first one, sorry. Okay, but don't worry. Now we're gonna do it together, and you can do it your way. But let's give Mercy and all of you a big round of applause. Thank you. So now that you had a chance to perform that, translate that picture program into a live action dance, we're actually learning something here. So I would like to invite you to look at your worksheets. And we're going to simplify these lines of actions or instructions. How are we going to do that? By next using another thinking map, which is, what is this? I've been teaching you this, boys and girls. A brace map or a bracket, and we use this to simplify or break down a whole into parts. Okay, in this case, these actions you see at the top. What is the first action that is there, or line of action? Clap. And in your worksheets, how do I change that so I do not have to draw or write that word clap actually 3 times? So what you can do is this. You can cross this out, and put 3x next to it. Okay? Now you might have another way to do it. You might just put 3 claps. That's fine also, as long as you're able to still keep the essence of that first line. In my thinking map, I'm going to write clap 3x, okay? Without actually having to write this 2 more times. Now let's look at the second line. How can we simplify that? There's 2 different actions. How can we make that simpler?
Could we put brackets around the behind head and waist and put times 2 and then erase the behind head?
You can, yes. So, because I don't have that much space, what I can do though in my own way is this. And also because I already started with this kind of format, So I'm going to perform behind head, waist, and then do them twice. But it's still keeping in the same format or essence as what your classmate just said. The third line is the same as the first line. So can we just say repeat first line? Is that possible? What do you think will happen? If you look at the picture program, can I even do that? Yeah, it's going to mess it up, okay? Because if I say repeat first line, I'm going to have to repeat second line also here. And there's none of that here. So all I have to do is just be patient and write clap 3 times again. But for those who are thinking that, you're thinking ahead, because there will be some puzzles and lessons where you get to repeat the entire group of lines instead of just one line at a time. But for now, because this is your first time, we're starting small. Now, left up, right up is kind of the same as the second line, except there are 2 different actions, right? But I can still copy that same format. Left up, right up, and do it again. And am I done?
No.
Nope. Just like the first and the third, I also write this. Clap 3x. And just like what some of you have discovered is all of these belong in one bracket. And outside that bracket, it's asking me to perform it 3 times. Now what do we do now? Laugh about it. Okay? And just write belly laugh. Any questions about how we simplified pictures or a picture program or multiple actions into a single loop? You think you can do this on your own? Well, let's check our objectives. Give me a thumbs up if you were able to repeat actions initiated by Mercy. Okay, that's more than half of the class. Great job. Let's put a check mark next to that. We don't have to revisit that. Give me another thumbs up if you were able to translate that picture program into an actual dance. Thumbs up. Great. And last one, were you able to simplify that multiple actions into one loop or single loop? Okay, so it looks like we've met all our standards, our objectives today. You get to go home early today and you get free pizza for lunch. But actually, we are going to have what we call an independent practice, just to see and assess if you're ready to do this and take it to the next level, okay? And after that, we're going to go online to see how this looks like on the code.org platform. So for the independent practice, you can work on your own, with a partner, or as a table group, okay? But this work or this song that I'm about to show you, you do not need to sing this song, okay? Remember, you are first graders. You're not supposed to know these songs. So use the back of your worksheet to try and see if you can kind of use the same concept of simplifying into single loop by using the new song. Ready? We'll give you about 5 minutes to work on this. You probably heard your parents sing this, right, at home? Or play this in the radio, or their iPhones, smartphones. You don't need to sing them. I was actually not kidding, not because you're not supposed to actually know them as a first grader, but because if you sing them, the last part, there are 2 different melodies, right? So some of you would want to stick to that yeah melody and you want to simplify that one way, while some of you can just combine that. So in essence, what we're looking for is just the lyrics. How do you simplify this so that all the lyrics are still there, regardless if you're singing it with the right melody or not? So 5 minutes to work on that. You can collaborate. and then we'll see like 1, 2 volunteers who want to explain their thinking.
See here? So that whole line is repeated twice, and then do the whole thing again. She loves you.
Oh. If they love like that, you know you should be glad 3 times, and then yeah, 7 times.
So she was, so the reason why I told you about we're just doing the line by line earlier in my example, and then it evolves into something more. So now they're combining within one line. You can combine yeah 3 times, put that inside a parenthesis, and then she loves you, put a bracket, and now put 2 times outside of it. So that is also okay. Anyone else doing it in another way? You get free stickers. So here. Thank you.
Did Mercy get your sticker?
Not yet.
Yeah, I need a sticker. I did.
The last yeah, we did it 7 times.
7 times, yeah. So you put all of this, combine this, and that's fine. But if you also want to stick to the melody, that's also okay. Yeah 3 times, yeah 4 times.
Is it all sung the same way?
Yeah, as long as when you look at it, it's still the same way. All the words are still going to be there.
No, but is it sung the same way? Is the melody the same way?
No,
Well, then I wouldn't put them all seven together.
but we're not singing it anyway, so that's okay.
Oh, okay.
But the idea that I want you to really understand is we begin with what, 10 lines? Now we can condense it into 4 lines maybe. So that is how do computers work to make our lives simpler and easier. Okay? So hopefully this exercise gave you an idea of what it's about in terms of the idea of loop. Any questions before we get our observer to engage us in conversation? As a student, any questions as a student in this activity? If you have any questions later on, you can always post them on todaysmeet.com, and I will make sure to look at it to address them throughout the day. So let's welcome Renee, who will give us some feedback regarding our TLO activity. And this is also your opportunity to comment and provide input. Maybe when we were doing the activity, you had some ideas how to do this in the classroom. This is that chance to share those out loud. Okay, Renee, the floor is yours. You want the microphone?
No, that's all right. Who needs a microphone? We all have our teacher voices, right?
Yes.
Okay.
I'm kind of sick, so.
I'm sorry. Maybe it was those 5 weeks in Europe that you just came back from on Friday. Safely. All right, so in looking at the groups, one of the things that's always really positive is the level of collaboration. And I think that it's been really obvious the way that the groups sort of, take turns and give everybody a voice. That's always important. We know that with our groups in class that a lot of times we have those kids who monopolize the groups and sort of take over, and then the other students who are like willing to let them do that. So that's always an interesting thing to go over. What else would you like to address?
You can ask them.
Observations?
Yeah.
Oh, the questions, the
Yeah.
reflection questions?
Yeah.
Great. So in reflecting back, I'd love to hear from everybody about what you thought worked best with your group. And don't be hesitant to maybe talk about what could have gone differently to make it more effective. Anybody have a thought? Yes, ma'am.
Well, I noticed with collaboration, some of us had different ideas than others, so it helped us think of different ideas to help us get to our solution.
That's always good because, as we know, there's sometimes more than one way to get to the solution. That's nice to be open to. Very good. Anybody else? Something that worked really great with your group? Or were your groups just already that awesome?
Tying and sharing the different, the different ways there were, to really address it. Sometimes some of us interpreted art a little bit differently, and then we collaborated as to why we thought it was like, one way versus another, or even a third, and then we came together. Well, it could have been this way or this way, collectively.
It's nice to be able to acknowledge that the people that you're working with might see things differently than you, and that you remain open-minded to that possibility. That's really great. Anybody else, something that you wish maybe, looking back now, you thought of, you thought, oh, maybe, yes, ma'am.
I'm still in my first grade.
I love it.
I like to work by myself, so I just did it by myself. But when I'm done, I like to look and see what the rest of the group did. Not that I'm going to change what I did, just to see if we match up.
And what if you don't? Who's right and who's wrong?
I'm always going to be right.
Oh, and so if they did something differently, are you willing to look back at your own work?
Only if I think I'm wrong. So refer back to the first rule.
How about the lesson itself? Is there any way that you would change to bring this to your own students, and how would you do that? Before I give you some idea why I chose to do the lesson, deliver the lesson the way I did. So any comments or any idea how would you teach this same lesson to maybe an older group of kids?
Well, even for, I teach 7th and 8th grade, even for older kids, I think this is great. I like how you have a checklist to, they know what they're expected to learn, and then they can check it off as they're learning it. So I kind of like that even for older kids.
Thank you.
I like how you use the thinking maps and use strategy where you use cross domains. I just wouldn't have ever thought of using thinking maps in technology.
And the reason for that is I want to, get the point across that these are just suggested delivery of the lessons, but whatever tools and materials, resources you're already using in the classroom, it's best to use them to deliver the content, because that will really get the kids to buy into what you're trying to teach them. Like these maps, they're not actually spelled out in the lesson plan. I have attached the lesson plan for what I just taught you, and they did not tell me to do most of the things that I've done with you right now. So it's okay to modify according to what your experience is and your comfort level and how you think it's going to be best delivered to the students. Yes?
Would it be still okay if you use the lesson, which is on the code.org?
Yeah.
Where you would use, arrow, 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 down, down, down,
Yeah,
arrow, arrow,
absolutely.
arrow. And then show them that there's a sequence going on here.
Absolutely.
Is there a way
Yeah.
so you could use that?
Yes, and in a few moments, I'm going to show you kind of like the online component of the lesson to do that blended learning component. The idea of the offline lessons is just basically how do you see coding integrated across the curriculum, and not just the academic, but a lot of them will be in the PE, arts, music, movement. And so, well, how do we get the kids to enjoy it without it being too foreign to them?
And that's what I liked about this. It did bring in music and
Right.
movement, which every
Yeah.
kid likes.
And all the things you can modify, just like the Taylor Swift. I have been using that for a while, but the music that they gave me are like nursery rhymes, perfect for teachers who are in the lower grades. But for like me, I want to get to, poppy and trendy, although that's an old song. So feel free to modify the lessons. But once you start looking at the lesson plans, they're going to start becoming confusing and complicated. And that's the reason why I have the checklist of the objectives. I wanted to make sure that I target and teach those objectives, because that is always what makes you be on page is, the lesson might say algorithm or debugging. I have no idea how to teach those because those are like really technical concepts. But if you go back and look at the objectives, they're very simple. They're actually things that are not computer science almost. It's just like breaking down things into a simpler way. So always is my advice is go back to the objectives of the lesson and try to, address that instead of just being bogged down by that computer science vocabulary that pops up and sounds so strange to you. Any other question?
I was thinking of a possible extension is like you give partners, give them one of them the full set of the complete thing, and then ask them to write it in shorthand in a loop without the other person seeing it, and then give it to them. And then they perform the task and see if it's actually.
Absolutely, and now you are actually advancing that and reaching that to students who this may be very basic for them. So it really is up to the kinds of students and the skills that they bring into the table. Anything else? You are now going to, I'm not rushing you, but it's just because I have to go pick up the pizza. So I'm going to show you a video because you're going to be doing what we call pair programming. And in pair programming, the idea is you're going to work with a partner because of two things. One is if you only have 10 devices in your classrooms and you have 20 students, well, that really does not happen, right? You have 20 students, all of them can code or program at the same time by doing pair programming. You can put 2 kids in one computer and you maximize your time and your devices. But more importantly, it also is used to demystify that concept that computer programming or computer science is a solitary activity, that it's only for those kids who don't want to be bothered by other people, who just want to go sit in the corner and geek out. No, we want kids to know that this is a cool thing to do and that they can actually collaborate, communicate, and have fun together. So while I go pick up the pizza, I'll show you the video of what pair programming is all about. Think about who is going to be the driver and the navigator, and then when we come back, I will show you how to get to code.org doing the pair programming. So one will be the driver and the other will be the navigator. The idea is for the next 15 minutes, work together to solve the puzzles, okay? And you decide who gets to go first, but switch. Make sure you have the chance to perform both roles, not just one. To get to the puzzles, this is where you go. You go to todaysmeet.com, and when you're ready, click here. Studio.code.org, it says online version, pair programming, the second one. If you don't see it, refresh your page because it probably has not reloaded there. So it's the second one. I'm also going to show you something brand new with the code.org website. Hopefully it works. If you've already chosen your partner, what you can also do after you click that is X that out first. Go to your name. Go to your name. You see how it says pair programming? Try to see and click that, and what do you see out there? So that you don't actually have to leave your computer. You can see what your partner is doing. So in my case, these are the people I see. I'm not sure if you will see the same people who are next to you. So if you see your partner, what's her name?
Or your girlfriend?
Sarah. What is your account name? Give them your account name because that's what's showing up.
1, 2, 3, 4, 5.
As a person, you get rid of all of your
So repeat. Oh, yeah, you do the keyboarding.
Is there like an okay?
Okay. So.
Didn't work with
Oh, look, something happened. I didn't do that.
Yeah, that might be a little
But it's the
bit
same one.
distracting,
Didn't you do it
just
first and then I did?
Oh,
yes. Now it's 3.
Right, repeating
Go
down.
down. 1, 2.
R. This one?
or
Yeah, the repeat. Okay, and